We gaze up at the night sky, filled with wonder. Billions of stars shimmer in our galaxy. But did you know that around many of these stars, planets orbit just like in our own solar system? We call these planets exoplanets. They are strange new worlds, waiting to be explored. Some exoplanets are very, very far away, but some are surprisingly close. We call these nearby worlds superlocal exoplanets. They are our cosmic next-door neighbors. These planets are fascinating to us scientists. They offer a unique opportunity to study worlds beyond our own. Imagine a planet with two suns, just like Luke Skywalker's home planet Tatooine in Star Wars, or a planet covered entirely in water, a vast ocean stretching as far as the eye can see. These are just some of the possibilities that superlocal exoplanets offer. The discovery of these nearby worlds has ignited our imagination. It has brought us one step closer to answering the age-old question: are we alone in the universe? Superlocal exoplanets are incredibly diverse. They come in all shapes and sizes. Some are giant gas planets, much larger than Jupiter. Others are small and rocky, like our own Earth. What makes these planets truly special are their conditions. Some orbit incredibly close to their stars, creating scorching hot surfaces. Others are tidally locked, with one side always facing the star, resulting in a permanent day and night side. These extreme conditions might seem inhospitable, but they provide a unique laboratory for studying the limits of life as we know it. Could life exist in the searing heat of a volcanic world? Or in the icy depths of a planet far from its star? Scientists are eager to find out. They are developing new technologies to study the atmospheres of these planets. They are searching for signs of water, methane, and other molecules that could indicate the presence of life. Finding superlocal exoplanets is no easy task. They are often small and faint, hidden in the glare of their host stars. But astronomers have become incredibly skilled at detecting these hidden worlds. One method they use is called the transit method. When a planet passes in front of its star, it blocks a tiny amount of the star's light. By measuring these dips in starlight, astronomers can infer the presence of a planet. Another method is called the radial velocity method. As a planet orbits its star, it exerts a gravitational pull that causes the star to wobble slightly. Astronomers can detect this wobble by measuring the star's light. The discovery of each new superlocal exoplanet is a cause for celebration. It adds another piece to the puzzle of our universe. It brings us closer to understanding the diversity of worlds that exist beyond our own. When it comes to habitability, Earth is the gold standard. It has the perfect conditions for life as we know it. Liquid water, a breathable atmosphere, and a stable climate. But could superlocal exoplanets offer similar conditions? Some scientists believe so. They argue that superlocal exoplanets could have liquid water on their surfaces, even if they orbit very close to their stars. This is because tidal forces from the star could generate internal heat, keeping the planet's interior molten. Others are more skeptical. They point out that many superlocal exoplanets are likely to be tidally locked, which could lead to extreme temperature differences between the day and night sides. This could make it difficult for life to evolve. The debate over the habitability of superlocal exoplanets is far from over. Only further research will tell us whether these worlds could truly be home to alien life. Seeds of life. Could these be the cradles of alien existence? The possibility of life on other planets has fascinated humanity for centuries. Now, with the discovery of superlocal exoplanets, this dream feels closer than ever. Could these nearby worlds harbor life as we know it? Or could they be home to life forms beyond our wildest imaginations? We simply don't know yet. But the possibility is exhilarating. Imagine finding evidence of microbial life on a superlocal exoplanet. It would be one of the most profound discoveries in human history. It would prove that we are not alone in the universe. Of course, finding intelligent life is even more unlikely. But even the discovery of simple life forms would be a monumental achievement. It would fundamentally change our understanding of our place in the cosmos. Super-Earths and mini-Neptunes. A planetary spectrum. As we delve deeper into the realm of superlocal exoplanets, we encounter a fascinating variety of planetary types. Two categories that have piqued the interest of scientists are super-Earths and mini-Neptunes. Super-Earths, as their name suggests, are larger and more massive than our own Earth. These rocky behemoths possess a gravitational pull significantly stronger than our planets. Imagine the towering mountains and deep canyons that could form on such a world. Mini-Neptunes, on the other hand, are smaller than the ice giant Neptune in our solar system. These planets are shrouded in thick atmospheres, composed mainly of hydrogen and helium. Could these gaseous envelopes harbor secrets of their own? The distinction between these two categories is not always clear-cut. Some planets exhibit characteristics of both super-Earths and mini-Neptunes. This ambiguity only adds to the intrigue surrounding these celestial objects. The Goldilocks Zone. Dilemma: finding the sweet spot for life. In our quest for habitable worlds, we often focus on a region around a star known as the Goldilocks Zone. This zone represents the sweet spot where temperatures are just right for liquid water to exist on a planet's surface. Earth, of course, resides comfortably within our Sun's Goldilocks Zone, but the habitable zones around other stars can vary greatly depending on the star's size, temperature, and age. Some superlocal exoplanets orbit red dwarf stars, which are much smaller and cooler than our Sun. The Goldilocks zones around these stars are much closer in, meaning that planets in these zones experience much stronger tidal forces. This raises a crucial question. Can a planet in the Goldilocks zone of a red dwarf star truly be habitable? The answer remains elusive. While liquid water may exist on the surface, the planet's atmosphere and magnetic field could be stripped away by the star's intense radiation. TRAPPIST-1 and beyond. Exciting discoveries fuel our curiosity. In recent years, astronomers have made remarkable discoveries that have fueled our fascination with superlocal exoplanets. One such discovery is the TRAPPIST-1 system, located a mere 40 light-years away. TRAPPIST-1 is a red dwarf star that hosts 7 Earth-sized planets, 3 of which reside in the star's habitable zone. This discovery sent shockwaves through the scientific community, as it suggested that planets in the habitable zones of red dwarf stars might be more common than previously thought. Another exciting discovery is Proxima Centauri b, a planet orbiting Proxima Centauri, the closest star to our Sun. This planet is slightly larger than Earth and lies within Proxima Centauri's habitable zone. These discoveries have ignited our imaginations and spurred us to develop even more advanced telescopes to study these distant worlds in greater detail. Peering through the cosmic veil. Advanced telescopes hold the key. Unlocking the secrets of superlocal exoplanets requires powerful tools capable of peering through the vast distances of space. Fortunately, astronomers are developing a new generation of telescopes that promise to revolutionize our understanding of these alien worlds. The James Webb Space Telescope, launched in 2021, is one such marvel of engineering. With its advanced instruments, it can analyze the atmospheres of exoplanets, searching for telltale signs of water vapor, methane, and other molecules that could indicate the presence of life. Ground-based telescopes are also undergoing a technological renaissance. The Extremely Large Telescope, currently under construction in Chile, will be the largest optical, near-infrared telescope ever built. Its unprecedented light-gathering power will enable astronomers to study the atmospheres of superlocal exoplanets in unprecedented detail. The search for another Earth. A journey of cosmic significance. The discovery of superlocal exoplanets has breathed new life into our search for another Earth. It has shown us that planets capable of supporting life could be far more common than we once believed. The quest to find another Earth is more than just a scientific endeavor. It is a profound journey of cosmic significance. It is a testament to our innate curiosity, our desire to explore the unknown, and our yearning to understand our place in the grand tapestry of the universe. Imagine the day when we finally detect irrefutable evidence of life on a distant world. It would be a moment that would forever alter our perception of ourselves and our place in the cosmos. An era of discovery. The future of superlocal exoplanet exploration. We are living in an era of unprecedented discovery in the field of exoplanet research. With each passing year, we uncover more secrets hidden among the stars. The future of superlocal exoplanet exploration is bright with promise. As our technology advances, we can expect to discover even more superlocal exoplanets, some of which may lie even closer to Earth than those we know today. We will delve deeper into their atmospheres, unraveling their compositions and searching for signs of life. The quest to understand superlocal exoplanets is a journey that will captivate generations to come. It is a journey that will challenge our assumptions, ignite our imaginations, and ultimately bring us closer to answering one of humanity's most profound questions. Are we alone